So we're now going to look at the effect of breathing mechanics. We know anatomically how we manage to breathe in and out, the muscles that are involved and the changes in volume and pressure. Now we're going to look at the dynamics, i.e. the different values and variables that we achieve through breathing. You may remember cardiac dynamics when we did the cardiovascular system. So there was an equation that we used to describe how we provided blood and oxygen for our muscles. And you should remember that it was cardiac output, Q, which was measured in litres per minute, equals stroke volume in millilitres, so that was the volume of blood per beat, times by heart rate, beats per minute. So how many times your heart beats, how much it ejects per beat, gives you a volume per minute. And essentially we've got an equivalent for breathing for air. Ventilation is the air we breathe per minute in litres, litres per minute, litres per minute. Tidal volume is the air that we breathe per breath. So if you think tides go in and out, we breathe in and out, it's each breath, and that's in litres, and breaths per minute, breathing rate. So there's if you kind of know this one, you'll be able to figure this one out. Make sure that you can define them, of course, and you will need to give values to each of those in the same way you'd need to be able to give examples for rest and for exercise for all of these values. So here's a graph really showing ventilation changes. Again, it's the same example I've used before when we looked at VO2. This is two people, pink and blue people, who are exercising progressively harder, so they're working at gradually harder intervals as time goes by. And you can see that the volume of volume of air, in litres per minute that they breathe, increases quite dramatically throughout this 20-ish minute exercise, starting at about 25. So they're already a little bit elevated. They'll be a bit nervous and have warmed up a bit prior to this sort of protocol starting. And during the first exercise bout, their ventilation increases to round about 55-60 litres per minute of air. If you think of a litre bottle and you think that 60 of those are going in and out of you per minute, that's quite dramatic. In the lull, in the recovery section, the ventilation values drop, and then when they start exercising again at a higher intensity, you can see that the ventilation might go up. The pink person here goes up to about 80, then it drops and it goes up to 85, then it drops, goes up to ultimately going up to about 140 during maximal exercise. So this is submaximal exercise and this is maximal exercise, going up to around about 140 litres of air, not oxygen, air, breathed in and out of your body, your lungs, per minute. So here are our definitions and some values and the units for each of those factors. Ensure that you could give in an answer examples of these. 6 litres is at rest, based on about 12 breaths and about half a litre being breathed. And it can go up very, very dramatically. I've put in red there actually somebody who might be highly trained or somebody who might be particularly tall, because the volume of air that your lungs can hold is quite strongly related to your height. So taller people typically have bigger lungs. So again, per breath you can go from half a litre to 3 or 4 litres per breath, from 12 breaths per minute to about 40 to 60, ultimately giving you a very dramatically increased ventilation value. MV over here is only because ventilation is sometimes called minute volume, and it's a shame we don't use that the whole time because it makes sense, the volume of air you breathe per minute. So here's a spirogram to show different lung volumes and capacities. You might be familiar already with tidal volume, the amount of air that you breathe per breath, but we've got some other things to pick out on this graph. Let's start over here. Total lung capacity, the total everything, all the complete volume of air that your lungs can hold. Now critically, when we try to measure volumes, we can't easily measure all of that directly. we always have actually some volume of air that we can't breathe out. We're left with a volume of air inside our lungs, and that's a protective volume of air to stop our lungs deflating. So there's about a litre-ish that remains in our lungs, and that's called residual volume. So if we measure what we can measure, so if I took the deepest breath in I could and breathed out as much as I could and measured it in a big bag called a Douglas bag, it's like a big plastic bag, what I could measure would be my vital capacity. I'd still not be able to breathe this out, but what I can breathe out is called vital capacity. Okay, so about 4.5 to 5 litres worth, vital capacity. So that's the maximum that I can breathe in and out. You'll see vital capacity plus the residual volume equals our total lung capacity. Tidal volume we've already talked about. At rest it's about half a litre or 500 millilitres. Now we can breathe in more. So if we breathe more deeply, as you'll see here when we're talking about exercise, we breathe in more. And essentially we've got this backup volume of air that we could breathe, or reserve volume. So here I'm breathing shallowly, a very small tidal volume. During exercise I might breathe in more and I might use some of my inspiratory reserve volume. And then I breathe out and I'd breathe out more. Now my breathing out volume is represented by the expiratory reserve volume. It's the extra that you can breathe out. I don't do it when I'm at rest, but when I'm exercising I'll breathe in more and I'll breathe out more. I'll take some of my inspiratory reserve volume and use some of my expiratory reserve volume. And you can see here, this is obviously this is representing exercise, extreme exercise, where you're breathing in as deeply as you can and you're breathing out quite deeply too. So if you were in maximal exercise, it's possible that your tidal volume might get as large as your vital capacity, this whole volume here. Again, have a look at this, some definitions. Residual volume, we mentioned the air remaining in your lungs after you breathe out. Vital capacity, the maximum volume of air that you can breathe in or out. Your two reserve volumes, the air that could be inhaled or could be exhaled. And there's some values here to represent how, or those volumes and capacities. We also need to know, in the same way we did for heart rate, we looked at heart rate and stroke volume and cardiac output changes before, during and after exercise. We need to know this, including the volumes. We might need to draw this graph in an exam question. So instead of looking at blood, we're now looking at air, and we're looking at ventilation, the volume of air that you breathe in litres per minute. We know but at rest it's very low, maybe 6 litres. Prior to exercise though, there may be a gradual increase, and again this is caused by anticipation and our anticipatory rise, perhaps adrenaline having an effect on our breathing muscles and stimulating us to breathe faster. In light exercise we have a rapid increase, and then we have that steady state plateau as essentially the same as pattern of changes as we did for the blood. And then in recovery we take a little time to recover, but we get back down to resting levels. In moderate exercise we have a slightly more rapid increase, and then maybe a slightly gradual increase and a slower recovery, rapid decrease followed by a gradual decrease. And in maximal exercise, again, an even bigger rapid increase, no steady state, we have a gradual increase until exercise stops, a rapid decrease, and then a slower gradual decrease until we would get back down to resting levels. But don't forget to recognise the values, particularly maximal and resting values for ventilation. Here's the language that you might be familiar with in terms of the graphs that we've looked at for blood, but it's exactly the same as I said. So the same language: rapid rise or rapid increase, plateau, gradual increase, rapid decline, and gradual decline. Remembering that it will be different for submaximal exercise and it will be more exaggerated for maximal exercise. No plateau, no steady state in maximal exercise, and recovery times will vary. So this is basically saying that during anaerobic high intensity activity, maximal activity, you will be slower to recover. Your breathing and ventilation values, breathing rate and tidal volume will remain higher for a longer period after you've stopped exercising, and that is to help replenish and remove all your waste products. So here's an exam question, typical exam question for this. This is asked you specifically to give a graph based on an aerobic event, so it's telling you it's a submaximal event. You should automatically know what the pattern of that should be. It's asked you to do it for minute volume, so you know it's going to be in litres per minute. And they've asked you specifically to talk about before, during, and in recovery from that activity. And this is the pattern that you should basically have in your answer. So anticipatory rise, rapid increase, plateau, rapid decrease, gradual decrease back down to lower levels. Again, here's a written version of the answer to that question. Lastly, one little snippet of information. In terms of tidal volume and breathing rate and how they change in exercise, it's just worth noting that tidal volume actually it changes earlier in exercise. So when you start to exercise, you'll initially breathe deeper. So you get more air into your body by breathing deeper, increasing tidal volume, which is really good because when you breathe deeper, there'll be better alveolar ventilation, and this means more oxygen gets deeper down in your lungs to your alveoli. This is a good thing. When you breathe more shallowly, you don't necessarily get as much oxygen actually getting all the way down into your alveoli. More later in exercise, we rely on breathing rate to get the volume of air in. And the trouble with breathing faster is you can't necessarily sustain the depth of breathing, and you might end up breathing more shallowly. And if you're breathing shallowly, the air will go into your lungs, down your air tubes, and all of it might not make it down to your alveoli. So your alveolar ventilation is really important, getting deeper breaths rather than faster breaths where you can. And I guess the implication for this is to try to control your breathing in exercise. When you get really puffed, you get quite frantic and fast breathing. It's very much breathing in the upper tract, the upper volumes of your respiratory system. What's more effective to get oxygen into your body is to have slower, deep breaths, so you get better alveolar ventilation. So it's just worth bearing that in mind.